Okay, so it basically comes from the complexity that is going into the vehicle now. Talk about trends, right? You talk about pace and space trends now, right? Connectivity, ADAS, electrification. A lot of software is getting in the vehicle. A lot of new sensors, new developments are happening in the vehicle. Now, when you have to test them, and which are very unique and new products, the complexity of testing as well increases. The need for simulating new kinds of sensors. You talk about ADAS, there are a host of new sensors, video, radar, and different LiDAR sensors. When you talk about e-mobility, they are not just low voltage, they are new sensors which are measuring battery temperature, battery performance, motor, so on. So a lot of pressure sensors which were there in the vehicle in the past because of the um, hydraulic systems are now replaced by electric, ADAS and connected vehicle, right? So the testing is also becoming that more complex at the moment because of ADAS. So it's important to also plan the testing right during the development. So there is no concept of develop and then test. So with the continuous integration and DevOps coming in automotive as well at the system level, it's important to test and define the test systems upfront in the development cycle. So testing all the mega trends that are now talked about, which are getting into every section in automotive, not just in passenger vehicle. They are also coming in commercial vehicles. They are coming in two-wheelers as well. So these are causing the testing as well to get much more advanced, much more complex, and these are also getting into a lot of custom development and custom testing. It's not like one test solution fits all. So we are focusing on a lot customization in terms of test development as well. So what we do when we talk about solution providing is we do have certain vector stronghold products in terms of software systems to test, softwares to test tools, simulation, like we have Dynafor, which is used for vehicle level simulation, and then we have the hardware in loop systems and the measurement and calibration systems, right? So we have these products which are developed by Vector, and these are getting into the test systems. But then there are also a host of other products which are coming in from other players in terms of power supply equipment, in terms of the loads and the sensor simulations that we do not cover in our portfolio. So we bring in those non-vector products, we put them together. We are only focused at what's the right solution for the customer to test a particular system. So we put them together. So we offer entire test solution which is built by Vector based on specific requirements from customer. And we bring in a lot of value add there to look at how do we automate that? How do we bring it in the development cycle in terms of continuous development, continuous testing? Plus, how are we able to scale these test systems? Because the vehicle architecture is also evolving, right? So OEMs are focusing on, at the moment, let's say, to bring together zonal and central computing in terms of cockpit, infotainment, and IVI systems. But then they would bring in ADAS, they would bring in vehicle dynamics over time, right? So these test systems should be able to, it should be possible to adapt them as we move in further. When we look at building test systems and defining test systems, these are happening in parallel. While OEMs are defining new architectures, they are also defining the test systems necessary for those architectures from electronics, electrical point of view, and the software applications point of view. So we are also developing test systems, we are gathering requirements, and the main lead time in these test systems is procurement of these products. The power supplies, the loads that are imported usually, those are the lead times. The other lead time is building a construction of test system, which could happen anywhere between 8 to 10 weeks. We are also advancing this at Vector. We are looking at how can we reduce this lead time. Whereas the overall design and definition of the test system would take 2 to 3 weeks, and multiple iterations can happen later as well, right? So since our test systems are modular, scalable, so even if let's say test system is at 90% completion, we can still bring in a lot more features or add multiple more new ECUs as well. We may need to adapt the wiring, but the software front end is simpler for us in terms of Kanu, which is a single software to interact with the entire test system as well as the ECU measurement. So it makes it much more seamless for us to adapt changes later as well. even after commissioning the test systems, the changes are much more quicker and simpler to bring it. We have built hill farms, hill big labs as well with the vector VT system as the base. So we make them modular in a way to support multiple ECUs together or single ECU in one way, or to bring the entire vehicle into the test system. Plus, what we also do is these modular systems are scalable at later point as well. So it helps to adapt to newer topics. And when you talk about OEMs are developing new technologies, so we are able to import these software requirements in a file format in the tools like Canoe. We are able to generate test cases with our software tools like Diva, diagnostic validation tool, which is an extension of Canoe. So it's a matter of importing those software requirements and generating test cases. And wherever we need additional hardware systems, there it's possible to plug in. When you look at the vector VT system, if you insert a new card, it's detected automatically by Canoe. Canoe brings up those card variables, and they are available for further enhancement of the scripts. So that's how seamless it is to make a system. There may be need to add some additional wiring, which could be done in a very short time. When you look at even the vehicle development, there's a lot of multiple player coming in even for one controller, each one providing different software modules, right? So when you look at test systems, we as Vector have very high focus on the ECU level, bringing the IOs, but then we have certain areas where we have to look at partners, right? So we bring in high voltage measurement, high voltage loads from other partners, or to bring radar simulators, we have a partner. So we work with multiple partners. So our tool chain gives the scope to openly interface with them. That makes it seamless. So we do work with the partners. Either if they are front-ending the customer, we work with them in bringing our know-how. And if we are front-ending, then we bring their know-how through them and offer the complete solution to the customer. I would say from testing point of view, IC is much more defined and evolved because we know what to test. We have all the simulation models available. When you look at electric vehicles, they are evolving the simulation models for the motor, for the battery especially. But then it's very important to focus on electric vehicle testing from the physical parameter point of view. There are changes, right? There is of course temperature measurement is critical, but then in IC engine there was pressure, there were a lot of other hydraulic measurements necessary, air temperature, air pressure, air volume. But when you look at electric vehicle, you're talking about voltages, currents, and other frequency and such base parameters. And with this, you should be able to quickly calculate complex factors, for example, power factor, efficiency, motor efficiency. So that's where we are bringing host of hardware sensors which can connect directly to the vehicle sensors, and then bring all this data into one single tool and quickly bring the calculations, complex calculations, which are even, at the time, not just mathematical, but also getting into calculus, differential, and so on. So not just linear calculations. So we have already delivered to OEMs as well as tier ones, individual hill systems to test battery management system, especially vehicle control unit, which is a lot more communication in terms of vehicle communication, and the motor testing. We have also delivered integrated test systems, which could test multiple ECUs together in the hardware in loop way, software in loop way as well. We have solutions for that. And what we have also introduced a very new product, we call it VIO, which is focused on ECU testing at a very early phase. What happens when you are developing a new ECU hardware in an A sample or B sample phase? You want to test each IO inside the ECU, each pinout. Typically, a hardware engineer probes them with measurement or oscilloscopes and looks at waveform level. So VIO helps in bringing this data into the software tool, into Canoe itself, which could be tested quickly, and then you can find out early issues in the hardware upfront and see what impact does it have on the software in terms of interference, in terms of variation, which would be very difficult if you find them later in a hill. So we are bringing in hardwares as well. We are bringing in abilities to enhance the Canoe, which is we call it Swiss Army knife of tools. Canoe, which can do test development, test simulation, test reporting, test automation, and also manage the hill. So in terms of test system developer, because that's what we are, right? Testing is of course done by the customer, or customer would engage a partner to do the testing, physical testing. But when we develop test systems, when trains are evolving, it's important to put a system together which is able to test connectivity, ADAS, e-mobility all together as well. Because you know, in a vehicle for a OEM, there's a challenge now. There are high frequencies, radio frequencies coming in vehicle. There are high voltages, high currents coming in the vehicle, and then there is a lot of software as well coming in the vehicle, right? So the impact of these electromagnetics on the software behavior and the impact of software on the hardware has to be done together during testing. So it's important to lay a very systematic plan for testing. There is a lot of focus coming in to test only software, the software as a code, right? So where we have the tool called Vectorcast, and we have also a very quick static analysis tool called PC Lint. When you test the software in its own source code level, then you are assured that the software is structured right, is enabled right, and is functionally right. But then you bring the software into the hardware and then start testing with the hardware in loop. This is next level. And then get the software along with the system as well, right? System could be a motor and a battery. We have measurement equipment, measurement sensors like D-temp, which goes on the battery pack, right? And we have also a lot of these high voltage measurement equipment which can either go on the vehicle or can do on the lab. But the biggest advantage is all the measured data is coming in a single tool, Canoe or Canopy, right? So the analysis becomes much more handy. There's a lot of data that has to be analyzed. It's almost like big data for an engineer at a tier 1 and OEM to work on. And it's important how you analyze the data. So graphical representation helps. A lot of video data is logged when you're doing ADAS testing. How do you utilize that video log? So we have Video Hill, where we are able to replay the video and test with a hardware in loop system as well. So the idea is not to bring a single test system. Idea is to put together, and ability to bring them together is very important, and should be also, I'm not just saying modular, but should be scalable. The focus could be certain systems today, but then OEMs keep on adding newer systems, and this could expand as well. So the same system should be scalable for the new requirements as well.